All right, here we go. It's study guide time. I am confident that if you have watched these videos, done the handouts, and done what you were supposed to do in class, you are going to be more than ready for this test on next week. So, but let's get this study guide done. Now, this says write an equation. I'm going to write the equations, but I am going to tell you that I want you to solve them. So when you get the key in Google Classroom, these equations will be solved and you can check your solving them. I'm only going to write them here on the video for the sake of time, so that I can get through the study guide quickly and get the video uploaded. But the key will have the whole equation solved, okay? So we're writing an equation right here. I don't like that brown. That's kind of ugly. Let's get another one. I can just use my black. Mom bought her children. Well, I picked up another brown. Mom bought her children 3 cartons of milk for $1.25 each and 6 donuts. So this is $1.25 per carton. We're looking for that per. So there's our variable term. 6 donuts is our constant term. The total was $6.90. So when we get ready to write our equation, we want a variable term, an operation, a constant term, an equal sign if it's an equation, and a total. Our variable term is going to be $1.25 per carton. Make sure you put your variable with your variable term, plus the $6, and it's going to be equal to $6.90. Now, keep in mind, our equivalent expression for that, our equivalent expressions, you could see it written another way. You might see it written 6 plus $1.25 x is equal to $6.90. You could see it written that way. You could see it written $6.90 is equal to $1.25 x plus $6. Or you could see it written as $6.90 is equal to 6 plus $1.25 x. Any one of those is an equivalent expression to that. Now, when you get ready to solve it, and if, when you solve it, you can solve the equation 125 x plus 6 equals 690. I don't care if you just solve that one. I just need you to be aware that these are all different ways that that equation can be written. You could see it any one of those ways. I need to make sure everything is in the screen. Hold on, let me check my... Let me back this out a little bit. There we go. There we go. Okay. So it's all there. But these are equivalent, equations. Those are equivalent equations, and it could be, and so you could see those written in any one of those ways. I cannot stress that enough to you. As you're getting ready and preparing for the test, I do not want you to be misled into thinking that's the only way. I just need you to be able to recognize those equivalent equations. Ms. Callahan just purchased a total of 8 shrubs and trees for her yard. The total bill was $260. The shrubs cost $25 each, and the trees cost $110 total. So here we go. Think about our per. This is $25 per shrub. The trees were your set amount. $25 per shrub, and your trees were your set amount. Here's your total bill. There's our total. So what do we have? We want a variable term of 25S for shrubs, or you can use X, plus the trees, and all of that equaled $260. I'm not going to write the equivalent expressions for all of these. I just need you to know the different ways that those could be written. During a film festival, the first film ticket priced at $16 and each additional ticket is $11. So the first film ticket priced at $16. And then each additional ticket is $11. So this is $11. This is per additional ticket. Okay, there's your per right here. This is $11 per additional ticket. Okay, this $16 is your constant term. And here's your total. So we have $11 x plus 16 equals 71. 5 sisters each bought a matching scarves and 2 pairs of socks. The scarves were priced at $12. If the total bill for all 5 sisters was $125, what was the price of 1 pair of socks? So, the scarves were $12. They bought 2 pair of socks. 2 pair of socks. So 2 pair of socks. There's our variable term. This one's a little tricky. Here's our total. But we got this 5 sisters right here. So let's think about this for a minute. They bought 2 pair of socks plus a $12 scarf. And the total was $125. But that 2 pair of socks and $12 scarf was purchased by 5 people. You've got 5 sets of these. If you think about this, think about it this way. We've got sister number 1, sister number 2. Let me move this over so you can see. Sister number 3, sister number 4. So here's sister number 1, sister number 2, sister number 3, sister number 4, sister number 5. She's going to buy 2 pair of socks and a $12 scarf. This one buys 2 pair of socks and a $12 scarf. This one buys 2 pair of socks plus a $12 scarf. 2 pair of socks plus a $12 scarf. 2 pair of socks plus a $12 scarf. We got to do that 5 times. So in order to, instead of having to do this, we come up 2 pair of socks and $12 scarf purchased by 5 people. That's gonna be an example of the distributive property. That's how the distributive property looks in a word problem. Miss Rogers' sister is 2 years older than Miss Rogers. Their combined ages add up to 88. How old is Miss Rogers? If you remember this week when we were talking about these kinds of problems, I told you to always, that the youngest, my thing right there, my little, is blowing out some aromatherapy, waking me up. He's pushing it out this morning. All right, so I told you to find the youngest. Who is the youngest? So you've got sister and Ms. Rogers. Okay? You've got sister and Ms. Rogers. Mrs. Rogers' sister is 2 years older. So who's the youngest? Mrs. Rogers. That's going to be your variable. The youngest is going to be your variable. Okay? The sister is 2 years older. So Miss Rogers is this old, and her sister is 2 years older than her. And together, they're 88. So we have Miss Rogers' age plus her sister's age, and together they equal 88. Okay? So on the ones like this, the youngest or the smallest, sometimes it's talking about 2 numbers, is the variable. Okay, your smallest amount's your variable, and then you build up from there. All right, so go back and solve these. I will be posting the key with them solved. All right, so let's get started solving. Some of these I'm going to solve. I may or may not get all of them solved. I may or may not work all of these on this video, but I will post the key with all of them worked. I want to, all right, so let me look at this page and see. I want to solve this one right here with this fraction. Negative 1/3 x is less than 5. I want you to look. This is 1/3 times x. 1/3 times x. If that's being multiplied, the inverse is to divide. So I'm dividing both sides by negative 1/3. This is a one step. There's only one operation in the way. The multiplicative inverse makes that a 1. So x, look right here. I am dividing by a negative. That sign has to flip. So x is going to be negative 15, but I'm going to show you 5 divided by negative 1/3 is a negative 15. Okay? Right here on this one. This was our weird one. This is the one I told you is the odd man out. This is the only one that we have to solve weird. And on this one, 4x plus 6 divided by 7 is less than 2. We got to get, that denominator's got to go. I mean, we got to get it out of the way before we do anything else. So this is all divided by 7. So I'm going to multiply both sides by 7 first. And what that does is that multiplicative inverse makes that a 1. So now I have 4x plus 6 is less than 14. I had to multiply both sides by 7, get that denominator out of the way. This is the only problem that doesn't follow our flow map. Now we're at our flow map, and we subtract 6 from both sides. 4x is less than 8. Divide both sides by 4. I'm not dividing by a negative, so I don't flip. X is less than 2. Okay? On number 11 down here, I'm going to let you're going to solve and graph those, and I will put the key for those in Google. It'll be on the key when I post it in Google Classroom. I'm going to let you do those on your own. Don't forget to use your distributive property right there. Look at this one. This is not even an equation. It's just an inequality. Don't let this mess you up. The only thing you have to remember when you're doing this one is the graphing part. This one, we want the variable on the other side. So we're going to mirror it. We're going to mirror it. So I'm going to put my x right there and my negative 3 right there. But we got to make sure the sign is doing the same thing. The mouth is opening up to the negative 3 over here. The mouth has to open up to the negative 3 over here. Now I'm going to use this to graph it. I just mirrored it, okay? We've just done some of the inequalities. So, I'm going to let you practice doing these. I'm going to post the key for the rest of this. And if there are any questions about any on the key that you don't understand, just let me know. But I want you to take some time and practice doing these, and then come back to the key and check your work, okay? So I'll get the key posted for you. But if you need any help with this, go back to the video that has this handout in it. These word problems right here will help you with these, okay? There is a video for just about everything posted, but I will put the solving on. I will have a completed key posted for you in Google Classroom. So have a great one. Study hard. Be ready.